I'll just give you an overview of what Innate Repair is, our venture, our experience at this forum, which was greatly helpful to us, and a little bit about our progress since last year. Innate Repair is a spin-off company from the Technische Universität Dresden in Germany, one of the centers of excellence in Germany, and it is registered in the UK, in England. And it's a biotech startup. And the problem that we're tackling is a problem that everybody is aware of. So if you look at the oncology field, it's gigantic. Whichever statistic you use is just in the billions and tens of billions and 1 trillion. And still, despite all these investments, there are many types of cancer where we have no solution whatsoever. So even a prominent US senator like John McCain, when he was diagnosed with glioblastoma, we knew he had 1 year to live, and he died within 12.5 months. So there's nothing that can be done. So this is pretty grim, and medicine has not yet found solutions to several types of cancer, but at least we have a better idea of what the specific problem that we need to solve is. And the best way to explain the problem, and also to explain generally why cancer can be so difficult, or many types of cancer, is if you picture a tumor as a tree. And it's made up of leaves, you see them in green, and those form the bulk of the tumor, just like the foliage of a tree. And those represent the fast-dividing cells within a tumor. And so current treatments are designed to kill cells that divide fast. So they kill the leaves, and the tumor shrinks. But just like trees have stems that grow much more slowly, but they feed the plant, so cancers have cancer stem cells. These are specialized cancer cells peppered within the tumor that they're quite different. They can divide very slowly, and so they evade therapy, and then they regenerate the tumor. And the key issue here is that the stems and the leaves are very, very different. So we need new therapies to kill those. And that's the task that we have ahead of us. And if you want to, I'll give you one specific example to showcase how difficult this problem is and how cancer has always so far found its ways around their treatment. Here's a drug, it's a JAK inhibitor, and a lot of people are studying it because it can kill the leaves. Well, we use it in our experiments every day because it feeds the stems. So you see what happens, right? You go to the doctor, they give you drugs, the tumor shrinks, and then after a while it comes back, they tell you, I'm sorry, it's not responding to treatments. Sure, it's not responding to treatments because you made it not respond to treatments. So it's a very complicated task. So here's where we come in, and our beginnings are very academic, from many years of research in the UK, in the US, and in Germany. And what we've done this is a summary of about 18 years worth of work, is we discovered a completely new molecular mechanism that is very specific for the stem cells, the cancer stem cells, actually stem cells in general. And we have published significantly showing that by manipulating it, by targeting it, we can have disease modification, that is change the health of experimental models. That model: ischemic stroke, Parkinson's disease, multiple sclerosis, type 1 diabetes, and type 2 diabetes. And then we thought clearly cancer stem cells probably use the same pathway, and they do, they use the same mechanism. After all, cancer stem cells are quite similar to normal stem cells, because cancer is essentially regeneration going out of control. So what our science can do more specifically is, here's the tree in a slightly more realistic model. So you have the leaves and the cancer stem cells peppered in there. And right now, there are many therapies that can target the leaves. Now, every time there's a new therapy that adds to this, I'm very, very happy. However, if you want to make the big leap and go to the next level in oncological treatments, you need to find at least one way to kill the cancer stem cells. And what we've done is we have identified and validated to a substantial degree several treatments that can do this. So some are new to man, they have never been used to people, but we have a lot of reason to expect low risk for these compounds. And other compounds are actually already approved. They're in the pharmacy right now, but they're not used for cancer. They're used for a different purpose, so we want to repurpose them in oncology, so the risk there is essentially non-existent because people take them. And of course, because we've been working for a long time on all this, we have companion diagnostic biomarkers to help us select the right patients, and the whole drug discovery method that led us here, all patented. These are parts of our assets. And we can do this at low cost, acceptable cost, because these do not involve these cell-based techniques that cost $500,000 per patient. The innovation here is the science, the delivery method is much more conventional. So with all this in mind, we thought let's just take off, let's just go form a company and make this happen. So what we did, we faced the first problem, which is I had no idea how to form a company. So we formed a team of very talented individuals, and we decided to just go for it. We got ourselves into this program, and then the good people at the MIT Enterprise Forum Greece held our hands for the next months, and we figured many basic things as to how to do it. And what we learned along the way was to define our assets and also learn how to present them to anyone who's interested. And so clearly our main asset is a unique know-how that we have, and we have been publishing this in top-tier journals over many years. So this is something that people can do their due diligence on. And it goes back to showing that this is our unique mechanism and it works. By publishing all this, we also receive recognition, so people writing about our works, commentaries, press releases, and even more importantly is when we see other labs, either academic or from large pharmaceutical companies, who follow up on our work. They say, oh, they say this thing should kill these cells and those cells and should work on many other tumors, so let me try on mine. And oh yeah, it works. So this is something that makes us really happy because we have everything patented, of course. So frankly, if you're a biotech company and you're not, and your asset is your discovery and you don't put it under scrutiny openly, I'm not sure you deserve to be thinking about putting your treatments into patients. Of course, we have taken care of the intellectual property. We have granted and pending patents, and we've done that very diligently and expensively as well by going into very good patent attorneys. That proved to be a good thing to do for us. And one of the things, of the many things that we learned at the MIT Enterprise Forum was to identify what your team needs. So we have enriched our team very significantly, and we have brought the precise talent that we need. So we are a spin-off from the University of Dresden, and they are shareholders. So this is fantastic for us because we have institutional backing, tremendous support from them. Well, I'm the scientist that is the inventor of all the science, so it's good for me to be involved. A major addition was Nicholas Kasapakis, who is a co-founder and investment banker, a very seasoned investment banker at a leading institution in the UK. So he has been a tremendous catalyst to get through the whole how do I form a company and how do I find people to give us some money. So he's been wonderful. And Stefan Bornstein, who is a departmental director, where my position is at the University of Dresden. And he is the recipient of the Order of Merit Award in Germany. He's somebody who really knows how to build bridges within academia and the industry. So fantastic human assets. And we also have a lot of other people who will be in our board and as consultants. Hari Hadzakis built his own med tech company from scratch. He's the sole founder and CEO of Biotronics 3D in the UK. So we have tremendous support in terms of helping us in our steps. And 3 very important people who are medics, and they can help us move everything to the clinical side of things in 3 very different locations. Derek is at the University of Chicago. He's the guy who runs the clinical trials for brain tumors, so can get better than this. Also, we published a lot of papers together. George Chrousos, one of the most renowned professors in Greece and beyond, and Ronen Lecker, director of the stroke unit and a great neurologist in Jerusalem. So just to close things up, what we've been up to in the last year, we registered a company in the UK, we got seed funding, we formed this team that is fantastic. We have completed our experimental design with a top research technology organization in the UK. We're ready to go. We published a paper, we published papers, but we published the first paper as Innate Repair, so that was a very sweet moment for me in particular, which was also well received, got press releases, so we got in the press as well. So now we're almost ready to start operations, meaning experiments, validate in preclinical models, pipeline 1, and also do initial validations on the other pipelines that we have. And eventually, somewhere there, we will want to get more money and go into people. Our vision is to start with a focus in oncology, all these treatments, and expand into different cancer types, and eventually extend our scope and diversify into neurodegenerative disease and diabetes, which is actually where I've done most of the work in my own career. So it's something that we can handle in terms of the subjects. So thank you very much. InnateRepair.com. Check us online, and I don't know if I can take questions. I'll be happy to.